This is section 5.6, exponential and log equations. So we're not really doing too much new here. We're just going to work through several equations. And I've put this box here to just remind you of the steps that we're going to do in each of these. Step 1, we're going to isolate the exponential expression. So if there's a number in front of it, we're going to get rid of it. Take the log of each side of the equation, and then we're going to apply either the inverse property or the power rule, solve for the variable. So you don't need to memorize that. That's just something that should just get us started here. But let's go ahead and look at this first one. The first one says 4e to the x equals 5, and that red part wouldn't be there. So let me get that out of the way because that's where we're going to start. And so isolate the expression. So this is our exponential expression, so we need to get rid of that 4. When we do that, we are left with e to the x equals 5/4. So then you're going to take the natural log of both sides, ln. So if we have ln e to the x equals ln 5/4. We want to remember the rule that says ln of e to the x equals x. So ln of e to the x, this we're left with x equals ln of 5/4. This is just a number. We're going to do it on our calculator, and so if we get the calculator up here, and we can just hit the ln button, which is right here, and do 5 divided by 4, enter. And I think the problems will typically tell you how much to round to. We're going to round to 4 digits. So that's approximately 0.2231. So if you were asked to give an exact answer, you would leave it as ln of 5 divided by 4. This is approximate. And there may be times where you're asked to do either one. All right, let's look at this one. And that is 4 to the x minus 1 equals 3 to the 2x. So we don't have to isolate. That just looks really ugly. I have to fix that. Okay, and that one's not matching. So 3 to the 2x. Okay, I'm happier now. All right, so we're going to take the ln of both sides. All right, now we have another rule that we use here because we don't have e in this one. ln of a to the x equals x ln a. And what happens when it's not an e, this power can go to the front. And that's the whole point, is to get x out of the exponent part so that we can solve it. So this and this are going to go to the front. Okay, so we've got x minus 1 ln 4 equals 2x ln 3. All right, now we're going to distribute. Since that's just a number, think about this. If I put this over here, if I had x minus 1 times 5, and I asked you what to do to continue, you would say, oh, you're going to distribute that and that, and you'd get 5x minus 5. That's exactly what we're going to do because this is just a number. So let's do that distributing, and we get x ln 4, because that's that times that, minus 1 ln 4 equals 2x ln 3. All right, now we're trying to solve for x, so we need to get the x things together. Let's go ahead and subtract this expression, x ln 4 here and x ln 4 here. These are completely different animals, so we really can't combine them. Disappears here. So we have negative ln 4 equals 2x ln 3 minus x ln 4. All right, so we got all the x's on one side. Now let's factor out x here. If I take x out of this thing, I'm left with 2 ln 3 and an ln 4. Okay, so 2 ln 3 minus ln 4. Okay, equals negative ln 4. Again, I have to remember I'm trying to solve for x. If that's the case, then I got to get rid of this whole thing. So I'm going to divide both sides by this whole thing. All right, over here, those cancel, and you can see that x equals this stuff. So if I were going to do that on the calculator, let's make sure we can put it in correctly. Clear. So I've got negative ln 4, close, divided by, and I want to put the whole denominator in a set of parentheses. So I've got parentheses 2 ln 3, close, minus ln 4, close, close. Okay, enter, and I get negative 1.709, and I think the question that I had rounded to 3 decimal places, so we would have that this is approximately negative 1.710. All right. Solving log equations. Those were exponential equations. Solving log equations. You're still going to isolate the log expression. Then you're going to exponentiate each side, which means you're going to take a base and raise it to what you have there. And then you're going to apply this property that says a raised to log base a of k equals the k. You'll see what happens when we actually start working on the problems. Let's try this one. So if we have log of 2x plus 1 equals 2. The rule says 10 here to the log k equals k. All right, so what we're going to do, we're going to say, okay, 10 raised to this equals 10 raised to this. So we've exponentiated both sides. Now, this rule, if we look here, what are we left with? We're just left with the k, which is this part here. All right, so now we have 2x plus 1 equals 10 squared is 100. Now we've got a regular equation that we can solve, and we don't have all this log business. So I'm going to subtract 1 and divide by 2. So x is approximately, well, actually it's exact 49.5. All right, let's try the next one. Log base 2 of 4x equals 2 minus log base 2 of x. Well, let's get the log items together. So we're going to add this. Do that on both sides. And so we now have log base 2 of 4x plus log base 2 of x equals 2. We're going to use our product rule, which says if you've got two logs added and they're the same base, you can write them as a single log. All right, so we now could write this as log base 2 of 4x times x equals 2, and that's log base 2 of 4x squared equals 2. Okay? All right, we're going to exponentiate both sides with a base of 2. All right, so we've got 2 to the log base 2 of 4x squared equals 2 squared. Remember that rule, log base a of log a base a of k equals k. Ultimately, what you're left with is here. So we've got 4x squared equals 4, x squared equals 1, so x is plus or minus 1. Now, you might see a different, this done a little bit differently once you get to here. You can, so if we had this, let me just show you another way to possibly do that. All right, so if we had the log base 2 of 4x squared equals 2, all right, instead of the exponentiating, you can say, okay, I want to change this into an exponential expression. Here's my base, here's my exponent, here's my argument. So 2 squared equals this. Excuse me. So you're doing the same thing. Your book is going to do it the way that I've been showing you, but this is also a valid way to just say, I know this is the base, I know this is the exponent, here's the argument. Base to exponent equals that, and you can go ahead and work that way. All right, let's look at the problem set and see what we can do. All right, here's the first one. Solve the exponential equation. Remember that we want to isolate first. So let's get rid of this 7. All right, so we have e to the x equals 19 over 7. Get a little more room here. All right, and so then we're going to take the ln of both sides. And remembering our rule that we're just left with this on the left side, ln of e to the x is equal to x equals ln of 19 over 7. If you do that on your calculator, you should get 0.9985. Okay. All right. Number 2. Solve this exponential expression. Again, we've got to isolate because the 1.3 is not being raised to that power, so we got to get it out of there. All right, we're left with e to the negative 1.5x equals 1 over 1.3. We'll take the ln of both sides. All right, on the left, we're just left with the negative 1.5x equals this. And then we'll divide both sides by negative 1.5. All right, so x is equal to ln of 1 over 1.3 divided by negative 1.5. Let's do that on the calculator and make sure that we can get that fine. So we've got ln of, whoops, I didn't mean to do that, 1 divided by 1.3, close, and all of that divided by negative 1.5. And we get 0.1749. So just be careful as you're putting things in. All right, number 3, solve the exponential equation. Since the bases are the same and we're saying this is equal, this one's equal to this one, then it should make sense that if the bases are equal, then these exponents have to be equal. So we can just drop the bases, and we'll have x squared equals 4x minus 3. So we have a quadratic. We know that we need to get everything on one side and 0 on the other. So we would have minus 4x plus 3 equals 0. And then we check to see if we could factor that, and we can. X minus 3, x minus 1 equals 0. So x is 3, x is 1. And I suspect, I don't have the actual problem set because I just grabbed parts of the questions, but I suspect you will just be putting in 3, 1 in MathLab. Okay, something like that. All right, number 4, solve the logarithmic equation. We want to isolate, so we need to get that 2 out of there. We'll have log x equals negative 2. You want to think about what's the understood base. I need to write that a little bit better. What's the understood base? It's not written there. It's a 10. Then we can do base to exponent. So we have 10 to the negative 2 equals x. You could do that on your calculator. I think it does want decimal answer. And if we did that, we have 10 raised to the negative 2. And that's going to give us 0.01. Now, if it says 3 decimal places, add a 0. I think it might do that. So even though it comes out even, if it says 3 decimal places, be sure that you do that. All right, let's do this log equation. What is the understood base here? There's not one written, so we know it's 10. So we can take 10 raised to the third equals 4x squared. 10 to the third is 1,000. 4x squared. Let's divide by 4. So x squared equals 250. And since we're trying to get x, we'll take the square root of both sides. So we have x equals plus or minus square root of 250. And so that's plus or minus 15.81 would be x. They may have the plus or minus sign in there for you, and you would only have to put in the numbers. All right, same thing with this one. There is a base there. We don't have to have an understood. It's 2 to the negative 2 power. So we've got 2 to the negative 2 equals 3x minus 2. So this is the same as 1 over 2 to the positive 2. So that's 1/4 equals 3x minus 2. Now we're going to solve this equation. We're going to add 2 to both sides. When you add 2 to 1/4, you get 2 and 1/4. So think about it this way. 2 and 1/4 is the same as 9/4. 4 times 2 is 8 plus 1. So we got 9/4 equals 3x. All right, now it keeps solving. We've got to divide by 3. So we're going to, dividing by 3 is the same as multiplying by 1/3, but over here, that's what I'm going to have. If I divide by 3, then I've actually got 9/4 times 1/3, which equals 9 over 12. Need a little bit more room. That's 9 over 12, or 3/4 equals x. Okay. All right. This one we're back to a little bit longer problem. We've got to start out and take the ln of both sides. So ln of 3 to the x plus 3 equals ln 4 to the x. Okay. Remember that the power goes to the front. Okay. So we've got x plus 3 ln 3 equals x ln 4. We're going to distribute here x times that and 3 times that. So we've got x ln 3 plus 3 ln 3 equals x ln 4. All right, we want our x's together and our number by itself. All right, so it would appear the easiest way would be to subtract this one to the other side. Alright, so I am left with 3 ln 3 equals x ln 4 minus x ln 3. Alright, I'm going to factor out the x. Equals this. And I'm going to divide both sides by this whole thing. And I want to make sure that I put that whole thing in parentheses. If you don't, you will miss the problem. Alright, so we can see this is gone and this is gone. So I have x equals this. Let's do it in the calculator together and make sure that we can get it. On the top, let's go ahead and put this in a set of parentheses as well, just to make sure that we're good. So we're going to have a parentheses, 3 ln 3, close, close, divided by, so see I had a parentheses around the whole top, parentheses on the bottom, ln 4 minus ln 3, close, close. I think that I've got it all. And 11.457 is what we get. Yeah, we're good. So we have, x is approximate 11.457. All right, let's look at number 8. All right, we're going to divide both sides by, well, first we're going to get rid of this 3 on both sides. So we've got 4 times 1.06 to the x equals 13. Then I'm going to divide both sides by 4. So I've got 1.06 to the x equals 13 over 4. All right, then I'm going to take the natural log of both sides. And so that becomes x ln 1.06 equals ln of 13 over 4. And we're solving for x, so we're going to divide both sides by ln 1.06. These, of course, cancel out. And we are ready to do our calculator. So let's see what we got here. We got ln of 13 divided by 4 divided by ln 1.06 and close. So 20.2279. Be sure to just look at your actual problem and see what it's asking you to round those to. All right, number 9. Again, we have the same bases, and we should recognize that these exponents then have to be equal. So we would have 7x equals 6x minus 5. Subtract 6x on both sides. You have x equals negative 5, and you are done with that one. That's a good one. All right, let's look at number 10. Solve this one. Okay, now this we get to use a little bit different technique. What is the exact answer and what's the approximate answer? So this one's actually pretty easy. You could write 9 as this base to some power. We could write that as 3 squared. Okay, so when we rewrite that, we have 3 to the x minus 7 is equal to 3 squared. And we're back to that idea that if the bases are the same, that these guys have to be equal. So we have x minus 7 equals 2. Add 7 to both sides, you get x equals 9. And what's the exact answer? We get the same answer no matter what, but we're going to go here and we're just going to put 9 on this one. It says, what is it approximated to 3 decimal places? So we're going to put 9.000. That seems very silly, but that is the way the wording of the question goes. All right, number 11. Again, we could rewrite 16 is the same as 4 squared. So we could write this as 4 to the x equals 4 squared to the x minus 1. When you write power to power, you multiply. So this becomes 4 to the x equals 4 to the, let's multiply, 2x minus 2. All right, now we got the same, the bases are the same. So now we know these exponents must be the same. So we got x equals 2x minus 2. Let's subtract the 2x this way. So we have negative x equals negative 2, which means that x is a positive 2. Okay. All right, now we have some log equations. All right, so the first thing we want to do, I'll write it down here so we can work on it. Isolate. So we're going to divide this 4 on both sides. So we've got log x equals negative 2. What's our understood base? We don't have one, so we always know it's a 10 if there's not one written there. And so then we can rewrite it as exponential. So we have 10 to the negative 2 equals x. Base to exponent equals the argument. 10 to the negative 2 is 0.010 equals x. It does say round to the thousandth, which is 3 places, so that's what you would need to put in the box. All right, number 13. ln x equals 5. All right, so we have another log equation, ln of x equals 5. Let me write that down here. ln x equals 5. We don't have a base written. It's not 10. When you have ln, the understood base is e. So we're going to have e to the 5th equals x. Now let's go to the calculator. All right. To get e, we do second ln. That gives us an e raised to a power. We're going to put the 5th and hit enter. And our solution says round to the nearest hundredth, so we would be 148.41. 148.41 equals x. So we'll go here and we'll put our 148.41 here. All right. Let me go back to here. Get the right question here. All right, so we're on 14. All right, we have another log equation, and we'll write it down here. Oops. All right, the base is understood to be 10. So we're going to rewrite that now as 10 cubed, 10 to the third, equals 4x squared. So 1,000 equals 4x squared. This is like our sample that we did. 250 equals x squared. And so x is the square root of 250. And that's going to be a positive 15.81, negative 15.81. Okay. And last one, 15. All right, let's write that one here. Log base 2 of 9 minus 4x equals 3. Base to exponent equals the argument. So we've got 2 cubed equals 9 minus 4x. 8 is 9 minus 4x. Subtract the 9 on both sides. We get negative 1 equals negative 4x. Divide by negative 4. You have negative 1 over negative 4 equals x. And then that'd be 1/4. It does say type a fraction, not a decimal. So we're here and we've got 1/4. So a lot of problems for that section 15. You may want to take a break in there, but I think this will definitely get you through 5, 6.